In this video, we'll be starting Chapter 2 Acids, Bases and Salts, and we'll be covering 2.1 Understanding the Chemical Properties of Acids and Bases. What are acids and bases? So, an acid is a substance that releases hydrogen ions or H plus ions when in water, and on the other hand, base is a substance that releases OH minus ions when dissolved in water. Acids taste sour, and some examples of acids include lemon juice, vinegar and hydrochloric acid or HCl. Bases on the other hand taste bitter, and some examples of bases include baking soda, soap and sodium hydroxide or NaOH. How to identify a base or an acid is if you dip a blue litmus paper in an acid, it will turn red. On the other hand, if you dip a red litmus paper in a base, it turns it blue. Let us understand what are other type of indicators that are used in order to identify these acids and bases. So, indicator can be defined as a substance that changes color depending on whether it is in an acid or a base. Some of the common indicators that we use are litmus paper, as we just discussed, a phenolphthalein indicator, which is usually colorless but turns pink in the presence of a base, methyl orange indicator, which is red in the presence of an acid and turns yellow in the presence of a base, and turmeric, which is a natural indicator, is usually yellow in color, but when it comes in contact with a base, it turns red. Let us take it some real life examples of these acids and bases and neutral substances that sit between acids and bases. Some examples of acids and bases, as we saw earlier, were lemon juice and vinegar. So these lemon juice and vinegar, when they come in contact with blue litmus paper, they change it to red. But when they come in contact with phenolphthalein indicator, the color does not change. Similarly, with methyl orange indicator, the color is red. Now, neutral substances such as water or sugar solution, they do not indicate any changes in any of these indicators. Basic substances such as baking soda solution, soap solution change the red litmus paper to blue but do not change the blue litmus paper, and the phenolphthalein indicator changes to pink and methyl orange indicator changes to yellow. Let us understand what are some basic chemical properties that these acids and bases show. Acids release H plus ions, as we discussed earlier. Acids are extremely corrosive substances in their concentrated form. That is, when they are not diluted in water. For example, sulfuric acid is extremely dangerous to our skin and it causes burns if we happen to touch it because it is rapidly dehydrating. Acids also are sour in taste, but again it is dangerous to go ahead and taste them ourselves. Acids also conduct electricity due to the presence of free H plus ions. The mechanism through which they conduct electricity will be discussed in the further sections. Bases on the other hand release OH minus ions. They are soapy or slippery to touch, although bases are also in their concentrated form not safe to be touched directly. They neutralize acids to form salt and water. Bases also conduct electricity. For example, sodium hydroxide. How do acids and bases react with metals? Acids contain H plus ions which are responsible for their acidic behavior. Now, when certain reactive metals come in contact with these acids, a single displacement reaction occurs. That is, the metal displaces this hydrogen ion to form water. This reaction can be summarized as acid plus metal gives us salt plus hydrogen gas. Let us take a look at an example. Zinc plus hydrochloric acid gives us zinc chloride salt and hydrogen gas. If we perform an experiment to test this, we have to start with a clean dry flask. We can start by adding zinc granules to the flask and then pour hydrochloric acid to cover this zinc. Once we close this flask with a cork and a glass delivery tube, within 3 to 5 minutes, we can see that a colorless, odorless gas is released. At this point, we can bring a burning match near the tube and see that the gas burns with a pale blue flame and a pop sound happens. This indicates the presence of the hydrogen gas. That is, the hydrogen gas was released through the tube due to which this reaction occurred. Some more examples of how acid reacts with metals include iron reacting with sulfuric acid to give us iron sulfate, salt and hydrogen gas, and magnesium reacting with hydrochloric acid to give us magnesium chloride and hydrogen gas. In both these reactions, we can observe that they are single displacement reactions where iron is displacing hydrogen and magnesium is also displacing hydrogen, and hydrogen gas is formed with a bubbling sound. However, there is an exception to it. Not all metals are going to react with acids to produce hydrogen gas. This is because reactive metals that are in the reactivity series above hydrogen, for example zinc, aluminium, sodium, magnesium, all these are going to react and displace hydrogen. However, the metals that are below hydrogen in the reactivity series, as we can see here, they do not react with the acid to give hydrogen gas. For example, copper, silver, gold, etc. Bases, on the other hand, do not react with metals as vigorously as acids do, but some amphoteric metals like aluminium and zinc, they do react with bases to give a similar reaction to that of acids, which releases hydrogen gas. An example for this is reaction of sodium hydroxide with aluminium, which gives us sodium aluminate with hydrogen gas. Another example is reaction of sodium hydroxide with zinc, which produces sodium zincate and hydrogen gas. Let us see how acids and bases react with metal carbonates and metal hydrogen carbonates. Starting with acids, acids react with metal carbonates or metal hydrogen carbonates to produce three products, which is salt, carbon dioxide and water. An example is calcium carbonate, which is usually formed in chalk piece or limestone. This reacts with sulfuric acid to form a salt, which is calcium sulfate, and carbon dioxide and water. Potassium hydrogen carbonate is another example where it reacts with hydrochloric acid to form potassium chloride, which is a salt, and also carbon dioxide and water. In these reactions of acids with metal carbonates and metal hydrogen carbonates, fizzing and bubbling occurs, which indicates the release of carbon dioxide gas. This carbon dioxide gas release can be tested by passing it through a lime water solution to see if a milky white substance, which is the formation of calcium carbonate, has occurred or not. Let us see this test with the example of sodium carbonate and hydrogen chloride, or sodium hydrogen carbonate plus hydrogen chloride. So a test setup is going to look like this, where we have a clean flask in which there is sodium carbonate or sodium hydrogen carbonate, and we use a thistle funnel to introduce hydrochloric acid into it, and we also have a tube that comes out in order to test the carbon dioxide that is released. So the reaction is going to be with sodium carbonate or sodium hydrogen carbonate, and when they react with HCl, we can see that sodium chloride, which is the salt, and water and carbon dioxide gas is formed. This gas is then passed through lime water to see if the lime water turns milky, which it does due to the formation of calcium carbonate. Bases, on the other hand, do not usually react with metal carbonates or metal hydrogen carbonates. Moving on to see how acids and bases react with each other. So when acids and bases are mixed, they neutralize each other to form salt and water. This reaction is called a neutralization reaction, and it can be summarized as acid plus base gives us salt and water. This is because H plus ions from acid combine with OH minus ions from the base to form the H2O molecule. The remaining ions form a salt. These neutralization reactions are exothermic in nature, which means they produce large amounts of energy in the form of heat. An example is shown here where hydrochloric acid, which is a common acid, is reacting with sodium hydroxide, which is a common example of a base, to give us sodium chloride, which is the salt, plus water. The reaction between acids and metal oxide also results in formation of salt and water because metal oxides are basic in nature, and oxide ion, that is O2 minus ion from the metal oxide, reacts with H plus ion to form the H2O molecule. An example for this is hydrochloric acid and copper oxide results in the formation of the copper chloride salt and water. Non-metallic oxides, on the other hand, react with bases similar to how they react with acids to form salt and water. This is because non-metallic oxides react with OH minus ions to form the water molecule. This can be written as base plus non-metallic oxide gives us salt and water. An example for this is calcium hydroxide plus carbon dioxide, which gives us calcium carbonate and water. With this, we have come to an end to part 1 of chapter 2.